Hey everyone, welcome back to part 5 of this series, which is the second part of looking at how we can optimize our database to work better for performance with Bubble's database system. So one thing I forgot to mention from last time is that in our pipe inventory list type, we obviously need to link each record to its parent item, okay, its parent record. And so what we have to do there then is create a new field, call it inventory, and make it the type of inventory. Okay, and that way when we're showing a list, what we can do then is click on it, and then we know which inventory item we have to then go and find to then go and display all of those details in a details pop-up or a details page. Okay, so the next thing that we're going to look at is data weight. So data weight is how much weight that you're going to download with each record of a particular type. So in other words, in this case with our pipe inventory, our data weight is effectively all of our fields. Okay, so the more fields that you've got, I mean particularly the amount of information you store in each field, is going to determine the weight of that data. Okay, so the way that we've organized this at the minute, that we've got inventory and then we've got an inventory list type, is you could say, and I do hear this a lot when I explain this to people, is why not just have one inventory type and do the group name thing in there, and then we don't have to mess around with a separate data list. We've got all the data in one type. And that's absolutely right if this is all it was going to be. Okay, so if it was just going to be these fields here and one relationship to one other table, then yes, we would. Honestly, quite honestly, that's exactly what we would do. However, inventory is notorious that the data weight of an inventory record could be huge because of the amount of sheer information that we may want to store about an inventory record. This could easily grow to 100, 150 fields on there. And remember with Bubble as well, you can't select what fields that you get back. Okay, unlike a traditional SQL databases where you can actually cherry pick which fields that you want back for a list, in Bubble you can't. You get everything back, so you've got to bear that in mind because that's your data weight. Okay, so with the inventory list type, yes, it may grow. We may get 25, 30, maybe even up to 50 fields in there, at which point you do start to look at it again. But also, if you purposely keep the data that is held in here quite lightweight, okay, in terms of the actual data that you store in there and also the number of fields, because you're never really going to need to store that many to display in certain lists. Okay, and again, you can be quite strategic about it. But with the inventory, this is our data container. This is where all our information about each inventory item is going to be stored, and this is never going to be displayed in a list. This is only ever going to be where you know the record that you want to get at, then you can go and just pull that information down. So a data weight in this type of thing is not that important. Okay, what is important is that, again, like we discovered in the last one, what is important is what you pull into a list, the amount of data that you're downloading. So if we look at data volume, is the number of records that you're pulling down, and data weight is the amount of data for each record that you're pulling down. If you times the two together, the volume by the weight, that's really going to determine how much data that you're asking Bubble to pull down and for your app to deal with, and that is going to affect performance. Okay, so the idea then is that all of the volume goes in the list and all of the weight goes in its main container type. That's effectively how we're going to deal with it. A good example is in an inventory type. Let's say that you've got like some kind of technical information, which could be pages and pages and pages of text in here. Now that's the data weight of that field then is going to increase the weight of each record quite substantially. Again, if we're pulling one record down, it's not really going to make too much difference. If we start pulling lists of that information down, or we just use this as a list, then that's going to have a real detrimental effect on there, because then we've got volume times by weight. So what you would generally do in that case is you would probably, in our list type, is just, let's say, store the first 100, 200 characters, maybe even less if you wanted to, into a field for the technical information. And that way, in the list, you're just showing a truncated version of that information. And then again, when they zoom into that, want to see the detail of it, then we just pull the information from the main inventory type. So again, data weight is crucial to performance. What you want to do is separate. If you need to pull volume down, which you generally do in a list, although even that you need to manage, which we're going to go through in a moment, but also what you definitely don't want to do then is to pull down volume and weight. So that's really important in terms of performance. Okay. So the next thing is constraints. So constraints are filters effectively, although I don't want to confuse the two terms because they do mean two different things in Bubble. So constraints are effectively what happens in our search here on our repeating group, and these are our constraints. At the moment we've got none. So constraints are things where you want to make sure that you're only pulling down the information that the user needs. Now at the minute we have no constraints, and that's very, very dangerous. We do not want to be in a situation where we're pulling down thousands of records before the user has had a chance to select which records that they actually want. I would always make sure that you do have a constraint on there. If you don't know what the constraint is up front, then what I would tend to do is I would actually not have a data source on the list, because that way as soon as this page loads, or whichever type of element you're showing the repeating group in, this will get triggered, and then if you don't have any constraints in here, that's going to pull down everything. Again, Bubble's going to try and optimize it. It's going to use lazy loading, where it only pulls down as many as you actually need to see, and then as you scroll up and down, then it will manage that. So Bubble will try and mitigate it, but we want to make sure that we have good practices here. So what we tend to do then is to actually clear the data source expression so that we don't have any data source by default. So what I would tend to do then is have what we call a conditional. Now, if you're not familiar with conditionals, a conditional is an absolute key element of the way that Bubble works, which is that when a certain condition is met, then you can fill out the properties of an element. So for example, let's say when you hover over a label, you can then say on the conditional is that when this element is hovered, I want to show it in a different color, as an example. In this case, what we can do is to say we don't have a data source, but maybe when something changes, when some condition is met, then we can put the data source on there. So what we can do is to define a condition, define another condition when a condition is met. So we can put something on there where the user can select something, and we can use that as a condition for it to specify the data source to get the data. So in other words, it's not getting any data until some condition is met. So what we can do there is to say, so let's say that we've got a checkbox. So I'm going to drop a checkbox here at the top. Okay, and let's call this, let's say I'm going to put a list whereby only the items that need to be reordered are going to be displayed in the list. So let's say I'm going to say items for reorder. I'm just going to put a label on there that says items for reorder. Okay, and back in our repeating group, on our conditional, we can then say that only when we refer to the CB, again, point and click. So this is why it's really important that you do name your elements correctly. So items for reorder, and then we can say is checked. Then we want to change the data source on our repeating group, and this is when we can then say that to do a search for, we can then say inventory. We're going to sort it by our SKU again, and we can add the constraint in a moment. But the point I'm trying to make is that, again, for performance, is especially if you imagine there are lots of data types where you know you're genuinely not going to get more than a few hundred records, and you can kind of be a little bit more liberal with that. But with things such as inventory, where there could be tens of thousands of items, even for things like customers and contacts, where you know that there could be huge amounts of information, and especially for transactions where it could be infinite, and you're just adding more and more every day, okay, then you need to be really think about the optimization. That's why I would suggest that you do not have a default data source on a repeating group, and make sure there's some condition to get there, even if it's just forcing the user to click a button to say get me the data, okay, and then set some condition and make sure that that's when you get the data. Don't just load a page and then you could be waiting for it to load. Okay, so that's what we've got on there. So let's have a look at constraints as well. So let's say, for example, we just said there items for reorder. So let's say that we want to have a constraint whereby only the items that need to be reordered are included in our list. Okay, so to do that, back in our data, what we will do is we will put it in our list type first and foremost, and we will say that it's going to be a reorder level. So in other words, this is going to be a quantity, and if the on hand is less than this reorder, then that means that the item needs to be reordered. Okay, and we'll also add it on our inventory group as well. So if you've got 10 in stock and your reorder level is 20, then you need to order more stock. Again, that's a number. Right. So then let's go back to our design, and we will implement that on our repeating group. Okay, so we're going to add a new constraint, and then we're going to say, okay, that when on hand is going to be less than or equal to reorder level. We can't actually select the reorder level, and this is one of the limitations of Bubble's constraints when you're trying to query or search for data, is that you cannot do field to field comparisons. Okay, so we're going to need to find another way around it. Now I'm going to go through a couple of options here, and none of them are viable apart from the last one, but I feel that you should be aware of them. Okay, so what we could do is get rid of that constraint, and what we're going to do is we're going to try and see if maybe Bubble's filter option will do the job. Okay, and that's why I said don't confuse filter with constraints. Okay, so this is a search that's going to basically go to the database, get our data back. Again, just remember we've got no constraints, that's going to get everything back at the minute. And then we're going to say filter. Okay, and then we can say add a new constraint here, and then we can say on hand, and then we can say is going to be less than or equal to, we still can't do it. We still can't specify the reorder level field, because with a standard filter we cannot do field to field comparisons. Okay, if you just do a standard filter with a search, that still gets run server side, so it's done on the database. Okay, but that's still not going to be the answer for us. Okay, we can achieve it, and the way that we do it is to use what we call an advanced filter. So we scroll down and we can say advanced, and then we can say that this inventory, so in other words the inventory item that is currently filtering through, and then we can say on hand is less than or equal to this inventory again, and then we can say reorder level. Okay, that will work. It certainly will work. It will certainly appear to work, especially if you've only got a small amount of data in there. However, big problems, dangerous problems actually with this, is you've got to understand how advanced filters work in Bubble. And that is that first of all you do the search for, and anything that meets that condition in the search, and we've got no constraints on there at the minute, so it'll just download everything. Okay, all of that data gets dumped down to the client side, and then the advanced filter gets run on in the browser effectively. So imagine you've got many thousands of items in there, and by the way, Bubble does have a limit to the number of items that it will actually download in any search. So therefore, if you've got a lot of items that are above that, it won't even get to those items. So therefore it's not really going to work at scale. But also, just even if it does download them all, imagine the speed of that you've got all that bandwidth that's being used up, all of that capacity just to get you this information back. So that's not the answer at all. Okay, again, gets all the data back within the search, and then filters it within the browser itself. Now if you're doing that filter and you know you're dealing with a data type with a few dozen or a few hundred records, that actually can be a great way to filter through it and can be very, very fast. Okay, so dismiss it completely, but certainly where you know that there could be quite a big, huge chunk of data that you just don't know how big it could get, do not apply advanced filters. Okay, so we're going to get rid of that. So what do we do then? How can we do that? If we can't do field-to-field comparisons on constraints and we can't use advanced filters, what do we do? And the answer is, with Bubbles database, is we need to have a calculated field which contains the result of what we're actually checking for. So if we go down to pipe inventory, what we can do then is we can create a new field, and let's say we're going to call that until reorder, and that is going to be the quantity. That is the difference between what is in stock, what is on hand, and what the reorder level is. Okay, so in other words, it's going to be on hand minus reorder level. Okay, so if you've got more in stock than what the reorder, if you've got more on hand than what the reorder level will be, then it's going to be a positive value. If the reorder level is higher than what you've actually got on hand, then that means it's going to be a minus value. Okay, so in other words, if the until reorder is less than or equal to 0, that means that it should be included on a reorder list. Okay, I hope that makes sense, because we can't do field-to-field comparisons, so we've got to have a field that's got the information at the point of putting the constraint on there. So what we can do whenever we're writing information in our system is we need to make sure that this gets updated, effectively calculated, which is on hand minus the reorder level. Okay, and that will work for us. So what we can do then back in design is we can simply then say on our search, add a constraint, we can then say until, where are we, until reorder is less than or equal to 0. 0 obviously means that the on hand is the same as the reorder, which means it should probably get included as well. And that's the way that we would do it. And again, that's another limitation that we need to take into account when we're designing our data structures, when we're designing how we want to query and search for data, that we have to take all that into account with Bubbles database system. Another thing to look out for as well is this ignore empty constraints. That can be really handy in certain circumstances. However, when you're in a situation where potentially tens of thousands of data items could be downloaded, as is the case potentially with inventory and also with transactions in particular, is you want to use that very, very carefully. You don't want to be in a situation whereby it could try and download everything. So usually when you're defining a constraint, usually this condition is not sort of static, it's not 0, usually it's something based upon an input box that the user's put in there. Okay, and if that's empty, then if you have that unticked, then what will happen is then it will react to that, so no data will get downloaded. If you tick that and they don't specify a filter, then it will get triggered. So therefore, just be aware of ignore empty constraints. They can be useful. I would tend to look at doing conditions and having multiple data sources, slightly more advanced, that we can sort of come into. All I'm saying is just be aware of it. Use it where it needs to be used, but be aware that there's the potential it could download a lot of data for you. So that all makes sense so far. So the next thing that we're going to look at is search types. Because in your system, in our system, I'm assuming that we're going to have some kind of search facility whereby the user can type in something and can search across the system. And maybe they can search for, with that, they could search for stock items, they could search for customers, they could search for within transactions, they could search for lots of different information. What you want to avoid in that case is to say, well, let's go and search in that type, and let's go and search in this type, and let's go and search in the other type to find the information that potentially that they want, because it's going to be difficult to query for that using Bubbles database. So generally, the way that you would do that is you would use search types, and I'm not going to claim credit for this. I've actually come across this concept by a guy in the community called Peter Amelie, and he's written a book called The Ultimate Guide to Bubble Performance, or words to that effect. I definitely advise you check it out. A lot of what I'm talking about here, sort of 50% was gained from that. I'm focusing on optimizing the database. He goes on to look at optimizing all sorts of things, We're not going to have the time to go through everything there, but definitely check out his book. It's not that expensive and will pay dividends in the future for when you're building your own applications. So search types basically is where we would have a single search type. Let's give it the pipe again, and I'm going to call it search. Okay, and generally what you would do then is you would have something that links it back. So in every type, as we covered very early doors, is that, let's go to app data and have a look. Every type has got a unique ID. Okay, so we can store that to reference everything. We don't necessarily have to have this type of thing where we give it a type. We can just store it as a text and store the unique ID. So what we can do then is, in our new search type, is we can just say data ID, and that's going to be a text. Okay, and then what we would do then is we would then have some way to identify what type of data it is that's being stored. So whether it's an inventory, a customer, a group, a transaction, whatever it may be. Okay, and generally the way that you do that is you would have option sets. We're not quite going into option sets just yet. If you know what option sets are, then you'll know how that would work. So we'd have a data ID, a data type, which would be an option set of all the different types you could have, one for customer, one for group, one for inventory, and so on, so that when the user search for something and they get a list of the results that match it, then you can say, okay, I know what type that they've clicked on and I know where to go looking for that. And then what you could do then is to just have a search field. Okay, and within that you could just name that as a text, and there are loads of different types of techniques that you can use for this. What you can do is to put like all of the key elements that you want to search for in this type, and then we can do a search which uses contains, so it searches within that field type. Okay, so search types again are a great way to have all of your data. Again, you're going to need to make sure that it gets updated with each update to a main type of data, but again you would use DB triggers for that. And this way you can store all of your search types in one table so that you can search across it, and that will make your searching extremely quick for your customers. We're only briefly covering this, but I just wanted to mention it as well. So I think that's as far as we want to go in this video. I hope that you've enjoyed it. I hope that you've got something for it. So in the next one, we're going to be covering how we can design our data and our data structures to fit within a SaaS application to make it work, not just for one customer like an internal tool, but for many, many customers who are going to buy this application. Listen, thanks for sticking with me. Thanks for your time. Take it easy, and I'll see you in the next one.